In this video, let us learn about some of the pathways that begin from the medulla. Let us start with the trigeminal lemniscus. Fibers carrying pain sensation from the head region reach the brainstem mainly via the trigeminal nerve. Their first order neurons are located in the trigeminal ganglion or the Gasserian ganglion. Upon reaching the pons, these pain-carrying fibers descend to the medulla as the spinal tract of the trigeminal nerve, and they relay in the spinal nucleus of the trigeminal nerve. So the neurons in the spinal nucleus will form the second order neurons. Axons of these neurons will cross the midline and ascend as the trigeminal lemniscus. They project to the contralateral ventral posteromedial nucleus in the thalamus. So neurons in the VPM nucleus will form the third order neurons. Fibers from VPM nucleus radiate through the internal capsule and corona radiata to project to the primary somatosensory area, which is located in the postcentral gyrus. So here they reach the area for the head region in the sensory homunculus. Some fibers from the spinal nucleus will project to the ipsilateral thalamus. Now, pain fibers from the head region may also accompany facial, glossopharyngeal or vagus nerves, and they will also relay in the same spinal nucleus of the trigeminal nerve. Therefore, they have the same pathway to convey the information to the cerebral cortex. Only difference is their first order neurons will be located in the geniculate ganglion or the superior ganglia of the glossopharyngeal and vagus nerves. Now coming to the gustatory pathway, fibers carrying taste sensation from the tongue, pharynx and epiglottis, they reach the brainstem via facial nerve or glossopharyngeal or the vagus nerves. Their first order neurons are located in the geniculate ganglion in case of facial nerve and in the inferior glossopharyngeal or the nodose ganglion in case of glossopharyngeal and vagus nerves. Upon entering the medulla, these fibers form the tractus solitarius and they relay in the nucleus of tractus solitarius in its rostral part, which forms the gustatory center. Now neurons in this nucleus will form the second order neurons. So axons which start from the nucleus of tractus solitarius leave the nucleus as the solitariothalamic tract, cross the midline, they ascend along with the medial lemniscus, or they may even accompany central tegmental tract, and they project to the contralateral ventral posteromedial nucleus in the thalamus. So neurons in the most medial part of this VPM nucleus will form the third order neurons for the gustatory pathway. Unlike some of the other ascending pathways in the brainstem, gustatory fibers project entirely to the contralateral thalamus. So no fibers will be projecting to the ipsilateral side. Now axons from this VPM nucleus radiate through the internal capsule and corona radiata to project to the lowest part of the postcentral gyrus in the cortex, that is area number 43, which is the primary gustatory area. Some fibers also project to the insula. Now from the primary gustatory area, there is projection to the lateral posterior orbitofrontal cortex, which acts as a site for integration, taste, olfaction and visual cues which are associated with ingesting food. Solitariothalamic fibers also project to the medullary reflex centers and to the hypothalamus en route. So these pathways may mediate visceral functions like salivating or gastric secretion associated with the taste. They may also mediate tearing and sweating associated with pungent taste. From hypothalamus, gustatory information reaches limbic system, including amygdala. Now this may provide an emotional context to taste, like this is like food made at home, that kind of emotions, or it helps in processing memories related to taste experience. Now coming to the vestibular nuclear connections. Vestibular nuclear complex is located in the pontomedullary junction underlying the vestibular area in the floor of the fourth ventricle. It's made up of 4 nuclei superior, inferior, medial and lateral. Medial nucleus is the largest and the inferior is the smallest. Lateral nucleus is also known as detus nucleus. Coming to its connections, all the vestibular nuclei receive inputs from the vestibular nerve fibers. Their first order neurons are located in the vestibular ganglion or the Scarpa's ganglion. In fact, it's made up of bipolar neurons. The vestibular information reaches the flocculonodular lobe of the cerebellum, both from the vestibular nerve as well as from the vestibular nuclei, as primary and secondary vestibulocerebellar tracts, or otherwise known as juxtarestiform body. Now, cerebellar cortex and the fastigial nucleus in the cerebellum, they project back to the vestibular nuclei. Both these afferent and efferent fibers pass through the inferior cerebellar peduncles. Vestibular nuclei also receive inputs from the spinal cord and the reticular formation. The lateral vestibular nucleus or the detus nucleus projects back to the spinal cord as the vestibulospinal tract. Now, fibers from the vestibular nuclei also project to nuclei of 3rd, 4th and 6th cranial nerves, as well as down to the spinal cord through the medial longitudinal fasciculus. Now, this connection mediates integrating vestibular signals with eye and the neck movements. It also projects to the cerebral cortex via thalamus. So, through all these various connections, vestibular nuclei influence the movements of head, eyes, trunk and the limbs to maintain the equilibrium. Now, coming to the vestibular inputs to the cerebral cortex, fibers carrying vestibular information travel in the vestibular component of the vestibulocochlear nerve. As we have said earlier, the first order neurons are the bipolar neurons located in the vestibular or the Scarpa's ganglion. These fibers enter the brainstem at the pontomedullary junction and relay in all the 4 vestibular nuclei. So, the neurons in these nuclei will form the second order neurons. Most of their axons cross the midline and they ascend with the lateral lemniscus and relay in the VPM nucleus as well as in the pulvinar part of the thalamus. As you have noticed by now, information from the body reaches the VPL nucleus in the thalamus, that is ventral posterolateral nucleus in the thalamus, whereas the information about most modalities from the head region reaches the VPM or the ventral posteromedial nucleus. From here, the fibers are projected through the internal capsule and corona radiata to the parietal lobe, which is adjacent to the head region in the sensory homunculus within the postcentral gyrus. Now, this is the primary vestibular area, and some of the fibers also reach the superior temporal gyrus through the sublentiform part of the internal capsule. Some of the fibers from the vestibular nuclei may project to the ipsilateral thalamus and ipsilateral cortex. So, primary vestibular area is located in the parietal lobe at the junction between postcentral sulcus and the intraparietal sulcus. This area is adjacent to the head region in the sensory homunculus, and it is concerned with conscious appreciation of the body position. Hence, it makes perfect sense for the primary vestibular area to be located here. And from thalamus, there is also projection to the superior temporal gyrus, which is going to be adjacent to the auditory area. Thank you very much. Hope you enjoyed this video. You can visit this site for other neuroanatomy videos. Thank you.